Welcome to Study Loop.
So we must algebraic manipulate equation 15.3 in order to make it look like the given equation in the problem. So we have y, x, comma, t. This is going to be equation 15.3, a cosine of 2 pi f, and then we have x over v minus t. So the first thing that we're going to do is redefine this v. We know that v is going to be lambda f, the wavelength times the frequency. So we now have a cosine 2f x over lambda f minus t. We also know that, first of all, I think we should distribute this. So we should have now a cosine. Then it'll be 2 pi f times x divided by lambda f. So it's going to end up to be 2 pi x over lambda, because the frequency is going to cancel out, and then I'll have negative 2 pi f t here. At this point, we can actually factor out a 2 pi divided by lambda. So it's going to now equal a cosine, and then it'll be 2 pi over lambda. And then it will only have x minus lambda ft. There's no lambda in this term, so we had to add a lambda in order to factor out a lambda. So we're essentially multiplying this term by lambda over lambda in order for us to factor out 2 pi over lambda. And then we, of course, know this relationship, so we can then rewrite this and say a cosine 2 pi over lambda x minus vt, given that lambda f equals v. So this is the given equation, and that's how we manipulate equation 15.3. Now, the second part of the question is asking us to find a equation for the transverse velocity. So this is simply found by taking the partial derivative of y with respect to t. And this is going to equal negative a sine 2 pi over lambda x minus vt, and this will be times negative 2 pi v over lambda, only because the derivative here would be negative v times 2 pi over lambda here. So at this point, we can rewrite this equation, make it look a little bit neater, and we can say 2 pi va over lambda, and then it'll be sine of 2 pi over lambda x minus vt. At this point, we can say that the max is when this term right here is going to be plus or minus 1. So first of all, this is b. This is the answer for b. And then part C is asking us, what are the conditions on the amplitude such that the transverse velocity is greater than the propagation speed, equal to the propagation speed, or less than the propagation speed. So this will reach a max. Vy x of t will reach a max. We can actually say that this is going to reach a max when this sine term is going to be plus or minus 1. We're going to take plus 1 just for convenience, and this will mean that the Vy max will equal 2 pi Va over lambda, essentially this term right here. At this point, we can say, okay, the propagation speed v will equal, the Vy max will equal v when, let's rewrite this. and say Vy max equals 2 pi Va over lambda. And so, okay, so Vy max will equal V when 2 pi A not V, over lambda equals 1, which means that A must equal lambda over 2 pi. And then the question is asking us, well, what are the conditions on the amplitude such that Vy max would be greater than V rather, which means that 2 pi A over lambda must be greater than 1. And this means that A must be greater than lambda over 2 pi. And then it's saying, how about Vy max is less than the propagation speed? Well, that means that 2 pi A over lambda has to be less than 1, which means that amplitude must be less than lambda over 2 pi. And so this would be these three conditions. These three conditions would be your answer for C, such that the maximum velocity in the y direction would be greater than the propagation speed, less than the propagation speed, or equal to the propagation speed. And that's the end of the solution. Thank you for watching.